Hey there, it's been a while since I made a video, but really haven't been doing much as far as like creating anything, so I didn't have any opportunity to make one. But now in the process of my Bearhawk build, I need to do some sheet metal work. So I decided to make a shrinker and stretcher stand. I'm going to go ahead and make a video or show you how I did the stand. Now whenever you're creating something for an aircraft, sometimes you have to do some metal work. And that involves taking the metal and moving it around and making little pieces. Let me put the screen around. Making something like this, and then shrinking it using some shrinking and stretching and whatnot, and to put curves in it, shorten the radius of the inside of a bend. You can extend the outside, do all sorts of fun stuff to move the metal around. Well, here's the shrinker and stretcher stand. It's not complete yet, but it's getting close. But if you look at it, the shrinker or stretcher, as the case may be, whenever you have it, you have the operating lever that extends out the back of the unit. Usually the ones that come, it's a handle that's about maybe a foot long. And to be able to use that and to put the metal in the shrinker or stretcher jaws and operate it, and to move the metal effectively with one hand while shrinking and stretching with the other, while this being clamped in a vise, usually doesn't work too well. So what people have done on the internet, and also they sell them as well, they make shrinker and stretcher stands that you can make or that you can buy that are operated by foot, and it takes a foot pedal and then a rod that comes up and actually bolts onto here with this replacement and actuates it with your foot, so you have both hands free to move the metal around. I decided to take a little bit more of a unique approach. Let me turn this back around here. I decided to take a little bit more unique approach to making the video, maybe make it easier for you to construct a shrink and stretcher similar to what I made. Like I said, I copied a lot of ideas off the internet, and this is what I came up with. This is what I have scrap for. Bought very few parts for this, just mainly the hardware. But the main idea is to go ahead and have something that you can operate with your foot. Like I said, I did something unique in this video that I think will help quite a bit in helping you construct a shrinker and stretcher stand. And at the end of the following vignettes that I've got recorded, I'll have the finished product for you, and I'll show you exactly how that works. So take a look about how it was done. Okay, so this is how it was constructed. I thought I'd do something a little bit different this time, in the sense that you're seeing the structure itself, but before it's painted. I went ahead and took a magic marker and I went over all the dimensions of all the places where I did some welding or added some pieces. So hopefully this is just like having a set of plans, but in video form. Starting at the top, I took two pieces. They're 3/8 inch thick, 3 inches wide by 10 inches long, just place of steel flat bar. And you can see that I took out a section, a 2-inch wide by 4-inch long section out of each little 10-inch chunk, and then I took those 10 inches and I welded them together here in the middle, and then this is all ground flat. So now I have a nice little cantilevered platform for the shrinker and the stretcher, and that gets welded to the top of the rectangular tube. Okay, now that we got the top part out of the way, we can continue on down the structure. Here underneath, I went ahead and welded a 1/4 inch thick piece of plate as a gusset underneath. I was looking at it. If you look at it, there's quite a cantilever here on this little 1-inch piece of metal. And I thought, well, if I'm going to be putting a lot of force on it with the shrinker and stretcher, with the control rod going up and down here, I figured probably wouldn't be a bad idea to help strengthen the structure. And I went ahead and got a couple of pieces of 1/4 inch plate. I actually had these gussets saved from another project that are sitting in my scrap pile. I just cleaned them up and welded them on. The main tube of the structure here, it's a 2-inch by 4-inch rectangular steel tube, 1/8 inch wall. It's 36 3/4 inches long. You can make it as long or as short as you want. I went ahead and did 36 3/4 because I wanted the jaws of the shrinker to be at least 41 inches off the floor, so it'd be a good working height. Moving on down, you can see there's a little bolt that's welded, a little 1/4-inch bolt on each side. They're just a mirror image of each other, kind of like a mirror image of the stuff on top. It's the pedal return spring mount, and it's up 19 inches from the end of the 2x4 piece of tubing, not from the very, very bottom, but from the bottom of the 2x4 piece of tubing. Moving on down further, we've got two sections of 1-inch by 2-inch rectangular steel tube, 1/8 inch wall, welded opposite each other, again like a mirror image. And you can see there's the tubing itself. It's a 6-inch long piece, and the hole for the bolt that basically is the axle for the pedal assembly is 5 inches from the end, plenty of space. And also on each side there's a 3-inch long bushing welded on each one of those. I was told from my son, who's an engineer, that engineers in general don't like cantilevers. And a cantilever, in the sense, is if you have something that is protruding out and then you have a pivot like this, and you don't have it supported on this end, that's a cantilever. So that just helps support the bolt that's going to be used for the pedal action going up and down. Those pieces of tubing are welded 4 inches from the end of the rectangular tube. And also, to attach the whole structure to the base, I've got a 3 1/2 inch by 2 3/4 inch plate, 1/8 inch thick. The dimensions are 3 1/2 inches this direction, 2 3/4 inches this direction. Okay, it bolts to basically this H, what I have on the bottom. It's two pieces of 1 by 2 inch rectangular tube, but the center part is a little bit different. The center is a 1 1/2 inch by 2 inch rectangular tube, 1/8 inch wall, and it's 22 inches long. So if I weld a 1-inch piece of rectangular tube on this side, 1 inch on this side, that gives a total overall length of 24 inches. Also, having that little 1/2 inch gap at the bottom right here, if your floor is a little bit even on the concrete, it's not going to rock on the center of the stand. So again, here's the 1 inch by 2 inch rectangular tube, 1/8 inch wall, 24 inches long. And then I welded on these little casters on the end. They're little 2-inch casters. So when the stand is laying flat on the floor, the wheels don't contact. But when I tip it back, the wheels do contact on the floor, and I can roll it around the shop really easy. And when it's sitting flat on the floor, the wheels are up off the ground. So here it is from different angles. I'll just kind of do a quick walk around the stand itself, where you can see how everything is basically a mirror image of itself. I only have the wheels on one side. And you notice also these bushings also give me a little bit of space between the pedal assembly and also the vertical tube. Okay, here's how I made the foot pedal. It's really easy to make. I just wanted to make it look a little fancier than just having a flat piece of metal on there. And it doesn't take that much extra work to make something else to make it look like that. That'll go on the end of the lever that you press down with your foot to actuate the shrinker or stretcher. I got a piece of 3 1/2 inch pipe. You can see it's an old scrap piece I had from my old scrap pile. 3 1/2 inches in diameter. I think it's a 1/4 inch wall. I cut off a 2 1/2 inch chunk. You can see how that was like that, the round chunk. And then I just sectioned it off and then made, actually there's another section that looks like another foot pedal, but I actually took 2 out of 3 sections and Didn't have to bend anything. I cleaned it up, and then got some of this expanded steel that I had also in my scrap pile. Just cut a little square of it and just went ahead and bent it around there, tack welded it all the way around, and makes it look pretty cool. Once I get it all cleaned up and welded on, put some paint on it, it'll just make it that much more nice. Okay, so now we need something to weld the pedal to. So here is the pedal assemblies. They're both duplicates, basically. They're just two of each. They're easy to build. So the basics are 1 inch by 2 inch rectangular tube, again 1/8 inch wall. And the total length is 22 inches from the end to the center of this bearing. And the little return spring bolt is welded 12 inches, a little 1/4 inch bolt that's sawn off, 12 inches from this end right here. And then the bracket that holds the pull rods for the stretchers is labeled, the little brackets, 16 inches from the end. So let's break this down one at a time. So I wanted to have something really strong on the very end. I don't particularly like bolts just spinning inside just solid welded tubes. And I happen to have a couple of bearings, or actually 4 bearings, that were just loose. And I decided to go ahead and put them into the rod or into the pedal ends, so it gives a really nice smooth action. So how do you do that? Well, I figured out that all I need to do is take some 2-inch steel tubing, and it's basically Schedule 80 pipe. It's about a 1/4 inch wall. And the inside diameter is just a little bit smaller than the outside diameter of the bearing, which is what I wanted. So just like I did on my grinder setup, I had to go ahead and put a bearing inside of this. So all I did was I took a section of the pipe, chucked it up in my lathe, and on the inside I slowly reduced the thickness of the wall of the tubing until the bearing was just a real nice slide fit on the inside. You don't need a lathe to do that. When I did my belt grinder, I didn't have a lathe, and all I did was take a grinder, and I just slowly ground out the inside, trying to keep it as circular as I could, just using hand tools, and then I just slowly but surely just ground it out till it was the proper diameter so the bearing would fit in. You can do that with either a Dremel tool, you can do it with a file, you can do it with any sorts of air tools that have any type of grinding or sanding type thing on there. All you have to do is just make it just a little bit larger in diameter and the bearing will fit. So I've got 2 bearings in here, if you look at it. I've got 2 bearings, and also what I had to do to keep the bearings from walking in and out as I'm using it, I went ahead and put in 2 1/4 by 20 set screws here that hold the bearings in place. Not a whole lot of force on these, all they are is just to help keep the bearings in one spot. When you put the axle through the bearing, and here's the bolt that I'm going to use for the axle, it goes in here, and then once it gets tightened up against the bushing that's welded onto the frame itself, it'll form a very tight and almost very smooth operation with little or no play in an axial fashion. In other words, it won't wobble back and forth. What kind of bearings are these? Well, glad you asked. The bearings that I have here are Fafnir 203P bearings, 2 of them. They're 40 millimeters in diameter, 17 millimeters inner diameter, and 12 millimeters wide. That's the width. Okay, so what's that in English? Well, I don't know. In English, it's real close to this bearing here, which is called a RLS5-2RS. 40 millimeter by 17 millimeter by 12 millimeter translates roughly, or almost exactly, to 1 9/16 by 5/8 by 7/16. These are available on Amazon. These are available on Amazon. If you want to go metric, you want to go standard, stay with these guys. Like I said, the only reason I've got these bearings here is because I had them on the shelf and I didn't need to buy them. I have little bushings in here that came with the bearings to kind of downsize the diameter, but that doesn't matter. You can make this any diameter you want as far as the axle goes. If you want to just go ahead and stay with this, all you need to do is get some 5/8 inch rod, and then you'll have a standard size axle that you can just go ahead and weld in there. Okay, I had to use something relatively strong for the tubing, but I didn't want to use my chromoly because the chromoly is $4 a foot, and I didn't want to use it just for doing that. I could get away with something cheaper. I had purchased these rod ends, I think off of eBay, I'm not really sure, before. It's a 3/8 inch right hand for one end of the tube, and then the other end of the tube 3/8 inch left hand thread, and with a weldable bung on the end. You can see all this is just a tube. What's welded on, which is really kind of cool about this tube, is just 1/2 inch EMT conduit, and it's 30 inches long. They sell them at Home Depot, a 60 inch long piece, basically 5 feet, for $2.50. I thought, well, shoot, that's a lot cheaper than using chromoly tubing. And the stuff is really strong. I mean, it's relatively thick wall. I think it's about 40 thousandths. And it's really strong and just needs to be in tension all the time. It's not in compression, so it should be plenty strong. So I went ahead and got 2 right hand ends, 2 left hand ends with a weld on fitting. And if you look at it, this is what I ended up with. This is the right hand side. If you look on here on the left hand side, it's got a little V just barely machined into the end to indicate that that's left-hand thread. It's almost like on a gas bottle where you have some type of explosive gas like propane or acetylene. They have a V groove cut into the flats of the nut that holds the regulator in to indicate left-hand thread, and it's no different than these welding bungs. And you can see I just went ahead and welded those in there, and you can see there's a little hole in the end. Well, the hole is a witness hole. They don't come with the witness hole. What it is, whenever you have a Heim joint, you have to have a certain amount of engagement of the threads inside of a Heim joint. Typically, what you need to have is 1 1/2 times the major diameter of the threaded portion of the Heim joint. So 1 1/2 times. So if this was, let's say if this was 1/2 inch, it's not, but let's say if it's 1/2 inch, then you have to have 1 1/2 times. So you have to have at least 3/4 inch of thread engaged. This is, I think, 3/8. I'm not really sure, or 7/16. I'm not really sure what the major diameter was anymore. But I went ahead and drilled a hole, not quite an inch, no, at 1.5 times the major diameter, but pretty close in the end, because it was really close to where I was welding it. That way I know that I have, when I have the threads engaged, and I can put a little piece of wire in there and make sure that it's engaged enough that it's not going to pull out even with a lot of force. So that was one little important deal that I put in there. I always had left hand and right hand threads on these, so whenever you have this installed, you can just rotate it in one direction, rotate it in the other, and that'll expand or contract the length of the control rod. That way you can adjust it depending on what you're doing. So that's it for all the little bits and pieces. Oh, by the way, I forgot, if you want to order some of the rod ends, this is what I got. They're 3/8 by 3/8 by 24 thread Heim joint with a weld-in bung. If you Google that, you'll get in the right spot. And all you need is 2 right-hand types, 2 left-hand types. And like I said, you don't need all this. I just thought it was cool to do. You can do fork ends on just regular steel rod. You can use all thread. There's all sorts of ways to connect control rod, but since I'm kind of an aircraft guy, I thought, yeah, what the heck. I'll go ahead and make basically what amounts to a giant turnbuckle. Alright, so we'll go ahead and get the thing painted up and go on from there. Okay, next we're going to talk about how to attach the control rods to the pedal and also to the top of the shrinker and stretcher. what I did was I made a couple of things. Normally it has a handle on the end of the shrinker and stretcher, but what I did was I took a couple of pieces of 5/8 inch cold rolled steel, 5/8 inch diameter, 4 inches long, and I made a couple brackets for them using some scrap pieces of square tubing. And here's the other one right here. How did I make these brackets? Well, these brackets are pretty easy to make. I just have this little scrap piece of tubing, and what I did was I went ahead and cut this off 1 1/8 inch this direction, 1 1/8 inch this direction, and then I had the basic U shape for this bracket. However, if you look at the inside of the bracket, when you take the joint and put it in there, if you have it set up like this, you got quite a bit of play between those. Now you can take that up with washers if you like. You don't even have to use this kind of mounting system. You can do whatever you want. You can use yokes, you can use all sorts of different things, but I thought I'd like them to have them adjustable like a turnbuckle. So I went ahead and cut them down to where they're a lot more close contact with the heim joint that they don't have much play. So what I did was I took and sliced it. Once I had this piece cut out, 1/8 inch, 1 1/8 inch here, 1 1/8 inch here, I went ahead and sliced out a 3/16 chunk down the middle, and then I took and clamped those two together and then welded it and then ground it flat. And then of course you drill the holes, just 3/8 inch holes, and I made 4 of those little brackets, very easy to make, and just welded them on the top. So that's it for the brackets that hold the control rods. Now we're going to talk about the control rods themselves. Okay, one thing I did forget to mention when I was talking about the pedal assemblies and everything is the little spring that suspends the pedal and gives it the spring action. And here it is. There's a little spring. And what it is, just a regular hardware spring. Got 2 of them at the local hardware store, my local trustworthy hardware dealer. And they're the Handy Pack. There can be any brand, I guess. It's 5/8 by 8 3/8, 0.62 wire diameter extension spring. Not too severe, I guess, of a spring, but not too light either. And how this works, real easy. Just take and loop that around that 1/4 inch bolt that I welded on the pedal, and then this loops up at the top, like so. And there you go, you got a spring. Pedal goes up and down. Of course, I don't have anything connected to it yet, so the upper travel is a little bit more than it probably would when the shrinker is on the top, but we'll see that here in the not too distant future. Alrighty, well here it is. Here's the finished product. I got everything put together, and I put up the control rods, and I've got it all finished up, and it works great. I got them labeled here because I can never remember the difference of the colors, which one's which. So this one here is the shrinker, this one over here is the stretcher, which is really nice. Now I can use both my hands to operate or to hold the metal on one side or the other, and I can use my foot to go ahead and grab onto the pedal and activate the shrinker and stretcher jaws using the pedal, and also the conduit rods here, the push-pull rods, or I should say just pull rods. They're adjustable, so if I need to pull the pedal up or down a little bit, I can do that. Here you can see a little bit of the detail of the bearings that I have in here that help with the cantilever. There's the bushing that got welded on to also make it a lot stronger, and then of course that's the back side of it. So you can see that it just sits there and rides on it. It's very smooth. And I can sit there with the pedal, and I can sit there and put it back and forth, and there's absolutely no radial play in there whatsoever. So it's nice and snug and a very smooth operation. There's one thing though that is a little bit different about this pair of shrinker and stretchers that have been modified, and I'll go ahead and show you what they are, or what the modification is. But to show you that, I'm going to have to pull the jaws out. So I'm going to go ahead and pull the jaws out and then come back to the video. Okay, I went ahead and walked over to my stretcher and my shrinker, and I picked the shrinker and took the jaws out of it. And I'll show you what modification I did to this that really helps when you're fabricating, especially with aluminum. You can see I have an alternate set of jaws in here. If you look at the jaws that come with Lancaster, there are some very deep parallel grooves that go the full length, or the full width I should say, of the block that is used in the shrinker and the stretcher. They're quite deep, and being hardened steel, those things are very sharp as well. Whenever you use them on steel or aluminum, especially aluminum, it leaves some very long, very deep grooves in the metal itself. In a sense, that isn't really much of a problem. However, it does when it comes to finishing it, and especially when it comes down to aircraft. In a high vibration environment, those parallel grooves, those deep grooves, unless they're completely removed, will cause stress risers, and it'll tend to crack in those areas. So you can go from 032 aluminum to 0.02 thin in a hurry when you try to sand these grooves out and to make those stress risers go away. Well, TM Technologies, Tin Man, Kent White, and his company, they ended up trying to find a solution for this issue that he was running across, and he went and had these jaws specially manufactured for his company. Here you can see this is called Stipple Finish Lancaster Shrink, and then we got the stretch, and they replaced the factory jaws perfectly. And what's the difference between these? Well, if you look at it, I don't know if the camera can pick it up, but these have a very smooth stipple finish on there, a very random pattern. It feels almost like coarse sandpaper. What that does for you is that when it grips the aluminum or the metal, whatever you're using, and pull it together, it just leaves a grainy surface almost like sandpaper. And it's very easy to dress those little areas out and not cause any stress risers like these really deep parallel grooves would. And here's an example of the piece of aluminum I used with the shrinker on here. And you can see it's just a little bit of rough finish. You can feel it's a little bit rough. But you can dress that out, no problem at all. And it's not going to cause any significant stress risers in the aluminum to where you're going to end up having a crack. And like I said, they make the jaws for the stretcher as well and the shrinker. The stipple finish on this one here is very fine, and usually use that for aluminum. They do make a second set, at least they did when I bought these, that's coarser than this finish here on these jaws, and that's more for steel, because the steel, when you compress it or expand it and put the pressure on these jaws, it won't sink in as deep, so you may need a little bit more resistance. But these little stipple finishes on here for the aluminum are just perfect. Don't distort the metal too much, and they're very easy to dress out. So that's it. That's my shrinker and stretcher story. I hope you enjoyed the video. And again, if you have any questions, feel free to email me, or I should say message me on YouTube, and I'll try to answer questions, whatever you have on the project or any other projects that I had here as well. Thanks. Have a good one.